P, they are the K, so they don't get grip in the brain. And for the K, yes. Really want
I'm trying to record. Okay, guys, so don't make me talk too loud either. This is about the loudest I can get right now. So let's start with 8-5 trapezoids. Does everybody have it out? Good. So, the gist of trapezoids, actually just in general knowledge. Definition of trapezoids is that there's exactly one pair of parallel sides. You can't have two. So if you have two pairs, then it's not a trapezoid at all. It would be a parallelogram, right? So trapezoids, exactly one pair. What's cool about trapezoids is that if you take, well, first of all, the two sides that are parallel, we call them bases. So that's a base, and so is this. And then the ones that are not parallel, they're called legs. Leg and leg. And then the really cool thing in any trapezoid is that if you take along the leg, so if you take these two angles, they're always going to add to 180. Same thing over here. These two will always add to 180. So that's kind of a big deal. That's how, when you're doing your homework, that's basically how you do like the first 12. Because all you're doing is you're looking and you're like, oh, these two have to add to 180. So if that's 75, I got to get 105. Does that make sense? So number 2, obviously, if that's 45, that's got to be 135. And so on and so on and so on and so on. Oh, good question. Because if you remember from chapter, I don't know, I think it was 3 or something, when you have parallel lines and you cut them by a transversal, remember how same side angles were supplementary? So same side interior are supplementary. Remember that? So these two are always going to add up to be 180. Same side supplementary. And all a trapezoid really is basically an extension of this. So if I have another, what do you call it, transversal, you have basically just created a trapezoid right there. So all these two angles really are pairs of same side interiors. So they're always going to add to be 180. And it also kind of makes sense because, you know, all 4 together are always going to get you to 360. So if you're going to have 180 and 180, there you go. Yep. So that's the gist for certainly 1 through 6, right? These are all straight numbers. Did you look at the answers already? I left this key yesterday, so I don't know if you.
Oh, she did not.
She didn't give us
Oh.
the key, she just sat in the chair and read a book.
Yeah.
It was miserable.
Well, that's okay. I mean,
That's what it said.
hey, listen, we're all on our last legs here. So let me show you the answers then. So here's 3 and 4. Do these make sense now that you see them?
Yeah.
5 and 6. So on your test today, you could get questions like that, right? Yeah. Okay. Now the next bit is a little bit trickier. So starting with 7 and 8, but you now have the tools to answer it correctly. So if you shimmy on down to 7 and 8.
So it would just be like 32x plus 1. Or minus.
These two are always going to add to 180. So that would be my equation, yeah, so I would just say 32x plus 1 plus 115 equals 180. And now solve from there. So any two along the legs of any trapezoid, always going to add to 180.
I think that one equals two.
Say that again,
I
sorry.
think pretty sure the answer of that's equals two.
It is. Very good. Right, so what's that? Oh, 32. I'm like, where, what am I missing here? Just got the problem wrong. So yeah, I get 2. Does that make sense? Okay, so number 8, it's the exact same idea. You're gonna add those together, 7 equals 180. Okay, so the answer there should have been 1 if you got it. Questions on the front? We're better now? And then on the back. Back is the same idea for these top 4. You're just gonna have all of these adding up to be 180. So just write your equation, solve, solve, solve. Easy peasy. Then, I believe the video at some point talked about isosceles trapezoids.
Yeah.
Okay, so let's talk about those real quick. If you have a trapezoid for those 2 legs, the sides that are not parallel, so these ones on the side, if they happen to be the same length, now we call this an isosceles trapezoid. So that's pretty easy to remember because it's very similar to the isosceles triangle. It just basically has its head cut off, right? So all the things, remember all the cool things about the isosceles trapezoid? 2 sides are the same, then 2 angles are the same. You get that here too. So these 2 base angles are going to be the same. And because the bottom ones are the same, that means the top 2 being the same also. And then the last really cool thing about the isosceles trapezoid, and this is only true in the isosceles trapezoid, it's not true in a regular trapezoid, it's that the lengths of their diagonals are in fact the same. So in other words, if it's an isosceles trapezoid, if I go from this corner to this corner, it's the exact same length as going from this corner to this one. So you're going to have equal diagonals. They do not bisect each other, right? If you look closely, it's very clear. Like, look at this one. This is definitely not being cut in the middle. I got this little tiny piece and this longer piece. So they don't bisect, but the entire length, let me put some letters here. So AC would be the same thing as BD. And that's the ticket to the last 6 on the homework. Because all of these are just giving you lengths of diagonals. So all you had to do was set those diagonals equal to each other and solve. So for example, number, is everybody okay with this so far? Can I cover this up? Okay. So if you're looking at 13, look at what they're giving you. DB and CA. We just talked about this and we just said they're equal to each other. So that's my equation. 3x minus 12 is going to equal 24. And then I can just solve for x from there. And that's how I get 12. And that's it. Does that make sense?
Yes.
So that's how you do the bottom 6. When you go to submit these, I'm not going to accept just a number. I would need to see the equation, right? So any questions on 8-5 at all? Anything I can do for you? Easy peasy? Yep, Wes,
When or what lessons does the test cover?
8, 1 through 5. So I'll review the others now. Okay, so the first page of your test is gonna ask you, I'm gonna give you a shape, and all you have to do is tell me what shape it is. And I know that sounds really easy, and it should be, but sometimes you get like too lost in your head, and I saw it on the homework. Like, if I give you this, I'm literally seeing some of you telling me that this thing is a rectangle. You learned rectangles before you started kindergarten. That's not a rectangle. You know it's not a rectangle. Since when do rectangles look like that? Never, right? Rectangles have to have right angles. So what is this thing?
Parallelogram.
That's a parallelogram.
It's a rectangle that was drawn.
And so you're not going to put rectangle as your answer. You're going to put parallelogram. If the answer was going to be a rectangle, it would have to look something like this. And it would have to have 4 right angles. If you don't have 4 right angles, you don't even have a chance of being a rectangle. The other things you might see are the markings. So one pair of opposite sides are going to be the same and the other is going to be different. So we usually put 2 slashes on those. So something that looks like that, if you remember from Sesame Street, you know that's a rectangle. So it might be helpful for you, right? Before you even start, I know you know what rectangles are. So look at all the questions and just pick out all the ones that are rectangles. Then maybe you do squares. I know you know what a square looks like. Of course you do. But sometimes when you're in it and you're like your mind starts playing tricks on you, just go back to Sesame Street and say, I know what a square is. Let me pick out all the squares. And so on and so on, and work your way down the line, right? So rectangle, squares, what do squares have to have?
4 equal sides.
4 equal sides and 4 right angles. It has to have both. That's what you're looking for a square. Okay. Rhombus is one that we mix up a lot. What do they have to have? That's a trapezoid.
They don't have any parallel sides, right?
They do. Both pairs are going to be parallel. But what makes a rhombus a rhombus?
It's orientation.
It's all the same.
All the same length sides. Yes, all 4 sides have to be the same. Wait a minute, isn't that a square? Isn't a square a type of rhombus? It is. Because the definition of rhombus is just a four-sided figure that has all 4 sides the same length. So a square does happen to be a type of rhombus. But this is what we'd be looking for a rhombus. All 4 sides have to be marked the same. It is still a type of parallelogram. It will still have both pairs of opposite sides parallel. But they also all happen to be all 4 the same. So all of these are types of parallelograms, right? So these are all like parallelograms, little children. What do you call something like this? Like that. What is this random thing? That, yeah, we just call it quadrilateral. Doesn't have any parallel sides. No sides are marked the same. This is just a random quadrilateral. gonna give you a big hint also. There is a four-sided shape called a kite, but we did not talk about kites. So none of the answers will be kite, so don't pick it. All right, so do you think that you could pick out? Like, oh, wait, and trapezoids real quick. And we just talked about those. So what does a trapezoid have to have?
Should be cool.
Hmm,
They're nice sauce.
A trapezoid has to have one pair of parallel sides. That's the key. That's how you know it's a trapezoid, one pair of parallel sides. Because it has one pair of parallel sides, you've got this pair of angles that's supplementary and this pair. But this is the driving factor behind that. So this thing is a trapezoid. And then you have a special type of trapezoid where those two sides, legs are the same. And that is called isosceles trapezoid. So it's just a special type.
When it has those little like lines, is that possible?
Yep. All right, so that's your whole first page. Your second page is gonna have a couple of things like. If I give you something like this and I say this is 80, this is 120, this is, I don't know, 100, what's this? You do that? How? They all add to 360, right? So, all right, that's easy enough. Now, if I have a parallelogram and I tell you and I only tell you that this one is 70 and I don't tell you the rest. Like, could you find, let's put some letters in X, Y, Z. Could you find all three?
Why does X would be 110? Why would it have to be 70?
Right, in parallelograms, the opposite angles are the same. So if that's 70, that's 70. And then you also have any two in a row are supplementary. So these have to be 110s.
Is it always one thing?
If that's 70,
Okay.
but if that were 80, that would be 100. You know what I mean? These two have to add to 180, whatever they are. So that's any type of parallelogram too, right? So it wouldn't matter if it was a rhombus, a rectangle, a square. Those things are still true. Rectangles and squares are easy because all four are 90, but also with parallelograms, remember that if I told you this side was, I don't know, let's say 8. What's this side? 8, right? Opposite sides of the same length. So that's easy. And then one other thing about parallelograms, if I tell you, so again, this is a parallelogram. What was going on with the diagonals? If I tell you this is 3, what's this one? 3, because the diagonals bisect each other. So if I told you this whole thing was 10, each piece would be 5, right? So that's easy, and that's true for any parallelogram. Diagonals are going to be the same. That covers us through pages 2 and 3. And half of 4. And then it's just trapezoid stuff, which we just went over. So let me just pick one or two tricky trapezoid ones. If I gave you this trapezoid and I told you that this was, let's do 60. Could you find me this angle right here?
No. No.
Yes.
This is not a parallelogram, right? So opposite angles are not the same. But if since it's an isosceles trapezoid, remember these little lines point at who's gonna be the same? So these two angles would be the same. If that's 60, so is this. And now what's true about these two angles right here?
Same.
They add to 180. These are same side interiors. So if that's 60, that means this top one is 120.
What would that be 120? Like, why would that?
Because 60 and 120 get you to 180.
Okay.
So in a trapezoid along the legs, those angles have to add to 180. Does that make sense? Okay. Yeah, and then that's it. Then it's literally what we just went over on the homework. So 2 in a row are gonna add to 180. Diagonals are gonna be equal. That's it. Any questions? Are you sure? Well, all right then. So if you would like to use a calculator, you can go ahead and grab yourself one.
You want to grab?
Just
They was a turn there, but. So, leave it in.
The last time.